Today we're learning about how mixtures compare to pure substances. Now, remember to make sure that you write down all of your objectives. Objective 1, Objective 2, and Objective 3.
Recall that we began taking notes on the different types of matter on a flowchart in last lesson. Make sure you put your notes for mixtures on the right side of this chart. So the key components of mixtures are that they have two or more substances that are not chemically combined, meaning they're not bonded.
Hi class. Okay, today we're going to look at these particle diagrams. Now, 1, 2, and 3 are all the same because they're pure substances. Now, this is so because each particle in the box is identical. Okay, now we know that the fourth diagram is a mixture because there are two substances that are combining, but they stay in their separate parts. So instead, they don't combine and form a new property. Okay, class. So, as we know now, the fourth diagram is a mixture, just like cereal and milk for breakfast.
So when you look at these two particle diagrams for mixtures, you can see that the various particles, in this case, the red particle and the white particle, are not bonded. In this other example, you can see that this particle that looks like a Mickey Mouse with a red head and white ears is not bonded to this single red particle. Mixtures are different than elements or compounds because they do not have a defined set of chemical or physical properties. For instance, the melting point and boiling point of salt water can change depending on the amount of salt present. Also, the density can vary as well in many different mixtures of salt water. The varying densities of salt water is one of the reasons why oceans travel around the world in a current called the Great Ocean Conveyor Belt.
All oceans and seas contain a mixture of salt and water, but the amount of salt in the water can vary. For instance, here is the Dead Sea. This woman floats upon the Dead Sea because its great amount of salt causes its solution to be extremely dense.
Mixtures, because they don't contain chemical bonds between the two or more different components, can be physically separated. Mixtures can be classified as either homogeneous or heterogeneous. These notes on mixtures should appear on the bottom of your flowchart. Place your notes on mixtures here. Homogeneous mixtures are mixtures that are uniform throughout, so they have no distinguishable parts, like chocolate ice cream. Gaseous mixtures, like the air we breathe, are always homogeneous. Homogeneous mixtures with water are called a solution, and they can never be separated by filtering. Their formulas will end with a subscripted AQ for aqueous. Again, that just indicates a mixture in water. Notice here this formula for salt water. I have the formula for salt, NaCl, and it's followed by AQ, meaning in water. This way I don't have to write H2O in addition to my formula of salt. Since water is called the universal solvent, or many things dissolve in water, this can be a great shorthand. Notice from the particle diagram that a homogeneous mixture is very evenly mixed. Heterogeneous mixtures have distinguishable parts. For instance, here we have a mixture of oil and water. You can see the different parts of the oil and water. So notice from the particle diagram that there are distinct layers or areas of different substances. Rocky Road ice cream or Chunky Monkey ice cream are both good examples of heterogeneous mixtures of ice cream with other delicious treats inside. Not every bite will be the same or uniform. There are different properties of matter, both physical and chemical. We use physical properties of matter to help separate the different components of a mixture. Chemical properties would be used to separate the components of chemically bonded substances like compounds. Physical properties of matter include their states of matter, which include solid, liquid, or gas, melting point, boiling point, solubility, magnetism, density, particle size, and color. Physical properties can be observed without changing the identity of the matter. So, for instance, if you take an ice cube made of solid water and you melt it, you still have water present. Or if you take salt and you dissolve it in water, you still have salt and water. Their properties are still present. Salt still tastes salty whether it's in water or it's dry. Chemical properties are properties that can only be observed when bonds are formed or broken. Chemical properties include how something reacts, burns, decomposes, corrodes, etc. Now, there's no definite way to determine if a chemical change has occurred in matter, but there are some key evidence we can look at, which are good indicators of a chemical change. And the more indicators we have, the more confident that we can be that a chemical change has occurred. The only way to really determine if a chemical change has occurred, though, is to make sure that the substance created has different properties than the original substance. Since the components of a mixture are only physically combined, we can use their physical properties to separate the different components. One of the key properties that we can use is particle size. Filtration separates components based on particle size, where small particles flow through a filter and large particles are stuck at the top of a filter. Homogeneous mixtures can never be filtered. Here you can see the kidney. That is a common filter used in our systems every day to filter out poisons and other wastes in our blood. In chemistry, we're most likely going to filter solids from liquids, like sand from water. Since we can't filter homogeneous mixtures, we have to have another technique for purifying them. Evaporation is one way to remove a solid that is completely dissolved in a liquid. Simply add heat. The liquid will form a vapor and leave behind the solid. Here you can see a sea salt farm where salt dissolved in water is placed out in the sun to dry, and the salt is collected and sold to people to put on their food. Distillation is another technique used to separate components of a homogeneous mixture. Distillation is typically used when the mixture is made of two liquids. Heat is applied to the liquid mixture. The liquid with the lowest boiling point should vaporize first. A thermometer will be used to monitor the boiling point of the different vapors. Once the vapor of interest is identified by its boiling point, that vapor will be allowed to travel through this condensation tube. In this tube, water cools the vapor so that it forms liquid again. Distillation is a process commonly used to purify alcohol and to distill water. The energy cost of distillation are quite high, so the water that we use for drinking is not typically distilled. The last technique that we'll discuss for separating the components of a mixture is called chromatography. You used this technique in living environment when you were trying to identify the components of a plant mixture to find the closest relative to a fictitious cancer-curing species called Botanicurus. In chromatography, the different components of a colored mixture are separated based on their difference in attraction between a stationary phase, paper, and a mobile phase, water. So you can see here, this black ink dot composed several different types of ink with different colors. So the yellow color was least attracted to the paper and dissolved best in the solvent, while the purple color was very strongly attracted to the paper or less easily dissolved in the liquid so that it remains towards the bottom of the paper. This concludes this video. See you in class.